Hello, welcome back once again, and a special welcome to all new viewers. This is a typical exam style histogram problem. So here we have a histogram that gives information about the heights in meters of trees in a park. The histogram is incomplete. As you can see, this bar is missing, and 20% of the trees in the park have a height between 10 meters to 12.5 meters. That is the bar that is missing. That represents 20%. None of the trees in the park have a height greater than 25 meters, so that is, there's no bar on this end. We're supposed to use this information to complete the histogram. But the first thing you need to remember is that we've not been given the total number of trees, but the histogram that is drawn, we can work out the frequency of each of the classes. And frequency is just equal to the frequency density times the class weight. So let's find out the frequency for each of the bars. So this one will be, and try to understand the scale. So this one is 2.5 times 1.2, because the class weight is 2.5 and the height is 1.2, that is 3. This one is 2.5 times 2, that is 5. So you do for all the known bars. So having known the frequency for each bars, we can now add the frequency of the known bars. So which means that these add up 32. Now remember, it said 20% of the trees between 10 to 12.5. So that is this point. That's 20%, which means the rest has to be 80%. So that means that 80% represents 32. With this, we can sort of use the frequency to do a scale to find out what is 20%. So if 80% is equal to 32, or represent 32, what should 20% be? You can see there's a link. If you divide 80 by 4, that will give you 20%. So we have to do the same on the other side, and 20% will give us 8, which means that the frequency for the class between 10 to 12.5 is 8. Now, having known that the frequency is 8 and the class weight is 2.5, you have to work out the frequency density. That will give you 8 divided by 2.5. That will give you 3.2. And therefore, we can now raise the bar all the way to 3.2. And that is our problem solved. So the important thing is work out the frequency of the known bars, let that represent 80%, and use that information to work out what 20% will be. And having gotten the frequency, divided by the class weight to get the frequency density and raise your bar to that level. We'll be looking at another exam style question.